And we're back for video 4. Okay, this is how we're going to do our working out videos. We're just going to do me holding my phone. I have ordered something to hold my phone for me, but until that comes in, my left hand's going to be holding it while I write with my right hand. So if it's shaky, I apologize. I'm doing the best I can do. All right, but let's work these problems out. Okay, so first one. It says determine the activation energy in kilojoules per mole for the reaction of ozone decomposing into oxygen gas and a singular oxygen molecule. If a plot of inverse temperature versus the natural log of K gives the following line equation. Now, I don't know if you remember, but what I said in the last video is that, if we look at our handy dandy piece of paper here, slope is equal to negative EA over R when X is inverse temperature and Y is natural log of K. Okay? So slope is equal to negative EA over R. So if we look at the line equation, we can get the slope, which the slope is negative 1.12 times 10 to the 4th. Okay? So negative 1.12 times 10 to the 4th is equal to EA, which is what we don't know and what the question is asking us for, divided by R. Okay? And R is 8.314 joule per mole Kelvin. Now remember, the Kelvin doesn't disappear in this equation, but this goes away, right? And it goes away because of X. Okay? Because EA is going to have the units of joule per mole because of R. Okay? But note in the question, it says kilojoules per mole because, as I said in my previous video, joule per mole is just super duper duper small. All right? Okay. All right. And I've already noticed that I forgot my negative here, and some of you may have been squirming to yourself as you're watching it. Where's the negative? Where's the negative? That was my bad. Okay, so EA then is going to be equal to negative 1.12 times 10 to the 4th times 8.314 joule per mole. Notice I'm going ahead and getting rid of the K. And basically then like times a -1 or divided by -1, something like that. Okay, so I'm going to get my calculator, which you should have too, right? I'm going to keep the camera on this while I do it over here. So negative 1.12 e to the 4th times 8.314 times -1. And I get a very large number. I get 9 points. Let's hold on to 3 sig figs. So 9.31 times 10 to the 10 to the 4th joule per mole. But of course, we don't want joule per mole. We want kilojoule per mole. And if you remember, there are 1,000 joules in every 1 kilojoule. So if we divide by 1,000, this should end up being 93.1 kilojoules per mole. Okay, so the first one, a lot more simpler than this second question. Okay, so let's look at the second one. This one's going to take more time. So the reaction of nitrogen dioxide and carbon dioxide leads to nitrogen dioxide and carbon monoxide leads to carbon dioxide and nitrogen monoxide. Ugh. Has a rate constant of 2.57 inverse molarity inverse seconds at 701 Kelvin and 567 inverse molarity inverse seconds at 895 Kelvin. Find the activation energy in kilojoules per mole. Now, this equation is that big nasty one that I told you that you didn't have to memorize. Okay? So it's this one. It's the natural log of K1 over K2 is equal to EA over R times 1 over T2 minus 1 over T1. Okay? Now, this is not dependent upon the reaction order. Okay? So it doesn't matter what the units of K are. Okay? Because they're dividing by each other, so they're going away. So this could be first order overall, second order overall, whatever. Right? Now, out of curiosity, based on this slide, you should be able to tell me what the reaction order is, though, based off the units of K. Okay? So K always gives me the inverse second, so that's not very useful. But it's also giving me an inverse molarity, which means there is one too many molarities in the rate law. So this is second order. Okay? But again, that makes no difference to the equation we're using. I was just thought I might take an opportunity to see what you guys could pull off from this, okay? All right, but let's start plugging some stuff in. It doesn't matter what you define as T1 and T2 either. I just usually start with the first one's going to be 1 and the second one will be 2, but it really doesn't stinking matter. All right, so I'm going to say the first one's 1. So then K1 would be 2.57. K2 would be 567. Okay, so ln of 2.57 divided by 567, ooh, it's not a pretty 5, is equal to EA, which we don't know, over R, 8.314 joule per mole Kelvin, times 1 over, now, if we look at the units of R, the temperature is Kelvin. Your temperatures for this equation, temps, must be in Kelvin. They must be for this to work. Now, in this question, they are in Kelvin. But why do you think I'm emphasizing this? I'm emphasizing this because I may ask you a question where the temperatures are provided in degrees Celsius. If I do not fall for that. Turn your temperatures into Kelvin. How do we do that? We had 273. Okay? They must be in Kelvin. Okay. All right. So 1 over T2. So my second temperature was 895 Kelvin. My initial temperature was 701. Now, next note. There's a lot going on here, right? Don't try to be the hero of the world. Do not try to do this all at once. It is pointless, and there's no one to really impress. You don't have to impress me. I'm happy with all your performances. Don't push yourself. Okay? So, if I were you, I would recommend solving this. This can be one portion. Doesn't necessarily mean you have to solve it first, but solve that. Then, solve this as well. Right? Solve those first, then worry about going from here. Okay? So I'm going to start with the natural log portion, this portion right here, okay? So natural log with my calculator, natural log 2.57 divided by 567. I get, and remember, hold on to lots of sig figs right now. So negative 5.3965 equals EA over R. I'm just going to rewrite that because it doesn't really matter right now. Divided or multiplied by, I am ignoring the cats. I know you can hear them, but I really just want to keep going. So now I'm doing the temperature portion. Now the thing here to be really careful about is put your fractions in parentheses. Okay? So fraction in parentheses 1 divided by 895 minus fraction in parentheses 1 divided by 701. Okay? All right. And we get negative 3.0922 times 10 to the negative 4th inverse Kelvin. Okay? Now, so you see that the inverse Kelvin is going to cancel with the Kelvin over here. All right, so that's gone. Now you can start trying to solve for EA. So your activation energy should be equal to this negative 5.3965, which is unitless. You're going to end up having to divide by this number. So it's going to be divided by negative 3.0922 times 10 to the negative fourth. You're going to end up multiplying by R, 8.314 joule per mole. Okay, so now we just need to calculate that. So negative 5.3965 divided by negative 3.0922 e to the negative fourth times 8.314. And I get 1.45 times 10 to the fifth joule per mole. But again, the question doesn't want to know joules per mole. It wants to know kilojoules per mole. So divide by 1,000, and this just becomes 145 kilojoules per mole, which is exactly what the slide says. All right. So this is the end of the 4th video. I will see you in the last video, video 5. All right. One more to go. It's going to be short. All right. See you in the last one.